dust off. All right, I'm just going to pull the camera up too. All right, so this is 213, week 2, and we're just sitting here in Grizz House 8. Not a bad hair day. But just wanted to dig into this one phaser problem. So as we go along here, I'm just going to go through a few Excel subtleties. So right here, this Q, which is normally on your keyboard, can also be turned into a symbol, a theta. And just don't ask me why a Q is a theta, because they're very, I guess they're both kind of circles with a line sticking out of them. But anyway, and you can see that the symbol is right there. You kind of highlight that that character. I usually and then just go up here and select symbol. So what I've done is tried to make a larger function for any phaser, and I messed myself up a little bit because I went from 0 to 360 in steps of 20. So all I did is I started at 0. I'm going to come back basically to 0 because on a circle 360 equals 0. So I'm trying to do the full circle, and you can see that these figures, start exactly where they end, just like any trig function would. Okay, so I'll put that aside for now. But what I'm trying to do right now, and just bear with me, is to actually get this 60 in here. Because I don't have a 60 in my table, and the answer, which I'll just show you, the answer, which is 173 volts, is not actually in my solution. So let me just bear with me while I tweak my Excel. And what I think I'll do is, instead of going in 20 increments, I'll just go in 36 increments in 10-degree increments. So let's just do this. 360 divided by 36. And you can see that all of that changed, because what I've got is, you can see that this, so this cell is B4. It equals 20. You can see that the rest of them also updated. Now the formula in here is B3, and that's what's called a relative reference. Because if I go down here, I can see that cell B5 references B4. And I didn't type any of that. Excel is smart enough to know what a relative reference is. And so every one of these guys, and again, if I go down here and I double click it, so if you double click that cell, it'll tell you which cells are feeding into it. So cell B8 is being fed by B3 and B7. So obviously B7 is the relative reference, one above, and B3 is the absolute reference, and that's what that $sign is. So maybe you guys know that. But
what's the quick way of doing the absolute reference?
It might be F4. I don't usually use it. I just type the $sign in. But anyway, if you know how to do that, that's great. Okay, so now I want to stretch this out to. I'm going to add. So I'm just going to click on this entire line with my left mouse, and now I'm going to right click and do insert. And now I'm going to put in a bunch more lines by doing Control Y, which is, so you guys know that Control Z is undo. Remember that? So Control Y is redo. So I'm just doing Control Y, Control Y, Control Y, instead of messing around with the mouse. Now, what I should be able to do is take all of these cells, and I'll tell you what the cells are in a second, and I've just highlighted them with the left mouse, and I'm going to drag them down to here. And I overshot it a little bit, but that's okay, better than undershooting it. I'm going to take these and just right click, delete. So I just populated that circle, or that graph, and we'll see how the graph turned out. Let me zoom out a little bit. If I click on one of these graphs, Oh. Oh, yeah, okay. I see the problem. The graph, when I copied this sheet onto this sheet, the graph is still from the previous sheet. So I got to do, and I'll come in and update that. But let's go back and take a look at this. So, and then I'll correct it. So the red line is sine, and that should look exactly like a sine wave to you, right? The green line is, it's not a cosine, it's the phase shifted sine. So the sine wave itself is just shifted by 60 degrees. So that's what that is. And then the purple one is the, let's just take a look. It's the sine plus the cosine, and the reason for that is we're going to, in order to find the phasor sum, we're using what's called the law of cosines, and that's why I've got all these funny little columns. So let's go back into sheet 3, and again, this is going to be chapter 3, problem 4, and I'll just call it 10 degree steps. The last one was 18 degree steps. So again, this was sine, and it should be, well, I should be able to just edit that box. Let me try to do that. So I go here, here, series 3, chapter 4. Oh, or I could do, actually, I know what I'll do right here. I'll just make this simpler, rather than trying to guess. I'm just going to call this thing 10 deg. So if I go and click, so I've got that guy open. Click the whole series. And up here I'm just going to edit this and call it 10 underscore DEG. Oh, I see. Oh, interesting. Okay. No problem. And it's, yeah, so it's 0, 10 degrees. Hang on 1 sec. Oh, gosh. Sheet 1, sheet 2. All right, never mind. I was gonna get fancy. I'm just gonna delete these and start over. I'll just kill the whole thing. So let's do this. Insert, because the independent variable was not showing it in degrees. It was just showing it in data points. That's what was screwing up. So I'll just start over. So insert. Charts. Go with this guy. And go with insert. Chart. Oh, no, hang on. Jeez. Highlight it. Insert. Charts. There we go. Okay. So now our degrees. I'm going to delete that one because that's just linear. Okay, so now we got for sine. 180, 360. It's going through. There we go. Sorry, I kind of dug a little bit deep in that guy. And I probably didn't do that the best way, but this the steps on. So here's your degrees, here's your radians. A couple different ways you could have done it. There is a function in Excel that's to convert from degrees to radians and vice versa. Instead of doing that, in the radians column, what I did was, again, I used the first value, which in this case is 0, and added this little reference value in A2. Let me make that a little bit bigger. It's too small to see. So if we go up here, so there's my degrees column. Here's my radians. Excel wants to operate on radians, not on degrees, and we can test that out by saying equals sign. So first of all, what is the sign of 90 degrees?
You
guys remember?
1?
Either 0, 1, and it's 1. So if we do sine of 90, that's not 1. It's kind of close, but it's not 1. But if we do sine of pi, and there's also a function in Excel, just pi. It has no argument, so it's just pi, open bracket, close bracket, sine pi. What's 90 degrees in pies? How many pies is 90 degrees? Half a pi, there we go. So pi by 2, ding, oops, equals.
Oh,
yeah, equals. So there's your 1. So that's just kind of sanity check. Like, okay, Excel wants to use radians. It does not want to use degrees. So, fine, dandy, good little test. Now this little number, and again, I'm not sure why I did it this way, but I did, and it's not the wrong way. It's just a little cumbersome because I could have just converted from degrees to radians, but I didn't. This number, 0.17, etc., is 1/36th of a circle, because one circle is 2 times pi, and well, let's just tell me radians are in a circle. You divide that by 36, and that's the number. So if we, get into your calculator here, you can say, okay, do I really believe that? Well, let's see, 2 times, maybe there's a pi on here, times pi equals, divided by 36 equals 0.17453. There it is. So all I've done is taken a circle and chopped it up into 36 parts. And the reason I did that is so I could make a nice little graph for myself. All right. So back to the relative references. I can see that each cell references the cell above it. That's the relative, the C6, but also this guy over here. And you'll notice that I've got $2 signs. So the first $sign fixes the reference left and right, the columns, and the second $sign fixes the rows. I probably only need to fix the rows because C is always 2 columns away from A, so that wouldn't typically matter. But anyway, there we go. Scroll all the way down, and we can see that eventually we get to 2 pi, which is 360 degrees. Okay, so that's That's the independent variable, just to make the dang plot. Now, what we want to do is come up with this solution. And so what we have here are two,
Sides.
what?
Two sides and an angle.
Two sides and an angle. But what these actually represent, this is a little bit of a mind bender, and some people's brains wrap around this just fine, and some don't, and you just kind of keep trying to wrap. But these arrows actually represent the direction that the phase is pointing. What the heck does that mean? Well, let's go back to the let's go back to this guy. Let me just close that door. So the top secret stuff. So
What?
so the red line is a sine wave, right? No mystery there, obviously. Duh. If it were coming in right here at the top, it would be a cosine wave, and that was back to what is the sine of 90 equal? Well, 90 is right there, and 1 is right there. I've multiplied everything by 100, obviously, and that's why it says 100, not 90. But so there's your sine wave. This next guy over is a phase shift. And if we shifted it 90 degrees, it would be a cosine. But in this case, we haven't shifted it. We've shifted it 60. Now, there's fundamental importance to this, because in a three-phase system, everything is 120 degrees out of phase, which in some ways is a little bit like being 60 degrees out of phase. That makes any sense? Like
Reference angle.
yeah. So so what I'm doing on the spreadsheet is just a fancy version of Pythagorean's theorem. And the fancy version of Pythagorean's theorem is called the law of cosines. So let's just go look that up. Law of cosines. Easy enough to do online. I really like Wolfram. Wolfram's got a
who's that one?
yeah.
Desmos.
Stephen Wolfram. I mean, the man is. I mean, he's just kind of a modern day Newton or Einstein, if you will. You know, solves math problems all day long, and wrote his own software basically to kick everyone else's tushy. So here's the law of cosines, and it looks a lot like. It looks a lot like Pythagorean theorem, I think. But let's use it. I'm going to see if I can bust out my little pad here. So we just have to do a tiny bit of algebra on this thing. This is where this stuff comes from. So here we go, Windows Journal, make that a little smaller, cheat off of Steven here, good old Steve. Where are we going? Okay, so in our case, we're just going to let C be that long side. So C is basically VA plus VB. All right, so that's the long one. Oops. Here's my pad. Okay, so I'll write down cosine B, cosine C. Let's use. Oh, it's right here. It's right here. It's just C squared equals A squared plus B squared minus 2AB cosine C. Now, the thing to keep in mind is that, I'll just rewrite that a little bit differently. The thing to keep in mind is that the lowercase variables are the sides, and these are the angles. So you probably remember from trig that if you know
Two sides.
As long as you know, like, two sides at an angle, you know everything. Or if you know all three sides, you know everything. If you're all, so as long as you know 3 out of the 6 things, you're going to be able to figure out the other 3. So in this case, there's 1, 2, there's 1 again, there's 2 again, and there's your third thing. So very, very similar to Pythagoras. So let's just see if we can apply that now to the problem. Let's see if I can get that and this on the same screen. Give her a shot. Okay, get here, scroll myself over, get up here. All right. Sine plus cosine, cosine squared, sum squared, 96. Yeah, I'll start fresh. I think I was doing something else on that, but let's just get the actual numbers going. So here's put in A, we'll put in B, we'll put in A squared, we'll put in B squared, we'll put in C, and then we're going to put in C in radians, and then we're going to put in cosine of C, and then we're going to put in C squared, and then we'll get C itself. Okay. So A is 100, B is 100, A squared equals that times itself. So I just clicked on the cell. B squared equals that times itself. C is equal to 60. C in radians equals radians. There's the function I was looking for before. Radians of C, dink, dink. So C squared equals A squared plus B squared minus 2 times A times B times, oh, I messed it up. I'm just going to pretend that's cosine of C for now. It's not, but I'll fix it. I'm going to put one more column in. Insert cos of C equals cosine of C in radians. Then I'm going to take this guy. Instead of that, I'm going to do this. Equals SQRT. All right, I know what I did wrong. Let's use 120 instead. 120. There we go. Yeah, there we go. Yeah, 120. Okay. Yeah, yeah. So the point is so 60 and 20 are related in that together they equal pi, but it's actually this angle. And so let's see, the cosine of 60 and it just likes that copyright, doesn't it? So the cosine of
120.
Yeah, cosine of 60 is 1/2. The cosine of 120 is negative 1/2. You're basically, if we go back to this guy, if we look at it for sine, I mean, you basically just flip from the top half to the bottom half is really all you're doing. The thing's symmetric. So anyway, that's how that thing runs. And for some reason these 173 is not coming out there. But anyway, that's how you run that thing. My other two sheets here were an attempt basically just to run this whole thing out. So you could see that if you were to have entries here and let this value vary between 0 and 360, obviously this guy's going to pop out when you hit 120. That's all I was trying to show there. Okay, anything else for 213?
Not really. I mean, if
Okay.
The other ones are.
if we just have, I think, if we're going to be doing a lot of phase, which I imagine we are,
Yeah.
I think we should do a little bit more of this maybe
Yeah.
in a lecture,
Okay.
so everybody knows how to set it up
Okay.
with like tables and then introducing unit phases and stuff.
Yep.
Because it's a lot easier to see that
Yep.
than it is to do the trig, because the trig's not that hard.
Right. Right.
But to figure out referencing what we're doing with triangle trig to what we're using it for actual electricity.
Mm-hmm. Yeah.
So kind of just something along those lines. 'Cause
Yeah.
I'm looking through the book and seeing like if we don't have something to reference back to for the phases, it's going to get a little interesting.
Mm-hmm.
Is my opinion.
Yep. All right, so we'll hit that a little bit more
Yeah.
next week then. All right. So I mean, obviously that's the formula. That's how I'd lay it out in Excel. I'd make sure I got a spot for each one. Yeah, so I can fix that guy up and do a little more
Yeah,
phasers.
so let's do 214.
All right, let's do 214.